Hey everyone, this is Derek, and in this video we're going to look at the quotient rule, and then I'll do some kind of combination problems of quotient and product rule from the last video. So the quotient rule is a lot like the product rule. It's the numerator is the same, except this one's a plus, that one's a minus, and then it's over the denominator squared. So I'll do the same thing here. I'll just kind of make a list. So my f is going to be the numerator, and then my f prime is going to be 3 times 2 would make 6x, take 1 off, that leaves 2, and then the 1 drops. G is going to be 5x plus 3, and then g prime, so 1 times 5 makes 5, and then take away 1 makes x to the 0, so just the 5. And now we just fill in here, so we're doing f prime times g minus f g prime over g squared. So f prime times g, that's this part. Oops. And then minus, and then again, I'm going to write it 5 times. I'm going to write it g prime times f, just because the multiplication looks better. And then that's all over g, the original denominator, and then squared. And so now I just need to clean up this numerator a little bit, and it will be there. So 6 times 5, that will make 30x cubed. 6 times 3 is going to give us 18x squared. 5 times 2 minus 10x cubed. 5 and 1, both negative, so positive 5. And then that will be over that denominator. Oops. And there, it looks like I got a couple of like terms, so we'll go 20x cubed plus 18x squared plus 5, and then over the denominator. And I should be writing that whole time that, let's see, this is y, so this is y prime, or again, if we prefer, dy dx. Okay, so on this example, it looks like we have a product rule inside a quotient rule, right? Because we have a fraction, so that's quotient rule, but in the numerator there's a product. So I think what the book is trying to get me to do is then to, what I just said is do the product rule, but what's easier than the product rule is just foiling this. So I'm going to cheat, and I would encourage you to cheat too and do the problem the easiest way available. So if I foil that out, I'm going to have 3x squared. Outside I get 2x, inside I get minus 12, so that's going to be minus 10x, and then minus 8 over x squared minus 3. And so that was easier than doing the whole product rule. Now I could just do power rule to the numerator. Still got to do quotient rule, but at least it cleaned up my numerator a little bit. What you'll see in later sections when we get like chain rule in this, that's no longer going to be an option, and then you would have to use the product rule in that case. But when it's available, do it the easy way. So that's going to make my numerator, I'll go, oops, that's not prime. F is going to be 3x squared minus 10x minus 8. So my f prime is now 6x minus 10. G is x squared minus 3, and g prime is 2x. And then we're just going to chunk all those into our quotient rule. And that was this guy right back here. So we go f prime times g. So that will be 6x minus 10, and then times g is x squared minus 3, and then minus for the product, or quotient, sorry, f times g. Again, I'm going to write that, or f times g prime, pardon me. I'm going to write that the other order just because that's often the easier way to multiply. So 2x, 3x squared minus 10x minus 8. And then all of that is over that denominator squared. Okay, so I got I got a bunch of stuff I gotta do. I got a FOIL here, I have to distribute there, and then I have to collect my terms. And what I am finding, I keep forgetting to write that, I'll write it over here, is f prime of x right now. So this is me finding my derivative. My goal was actually, I don't think I said at the beginning, my goal in this one is to evaluate that derivative at 2. So I'm trying to get, really from here, I could now just shove in a 2, because that's the derivative, and then grind that all out with a calculator. I'm gonna finish this out and clean it up, because this could have just as well asked you to find f of x, which you'd need the simplified form for. So let me show all the steps. 6x times x squared, so that's gonna be a 6x cubed. On the outside, we got a minus 18x, inside minus 10x squared, and then last plus 30. 2 times 3, so 6x to the third, plus, because of the double negative, 20x squared, plus again, 16x. And that's all over that, again, x minus 3 squared. And so now I gotta find my like terms. Okay, cubes cancel, so those are gone. And I got minus 10x squared plus 20x squared, so that's gonna leave me 10x squared. So I got that one and that one. Minus 18 plus 16. So that's gonna leave me minus 2x. And it looks like just that 30 is the only other thing. So plus 30 over this. So that is my f prime. Sorry, this is like a bad handwriting problem today, sorry. And now what I'm trying to find is f prime of 2. So I'm just gonna plunk a 2 in here and then kind of see how it comes out. So this will be 10, 2 squared minus 2 times 2 plus 30. And then over 2 squared minus 3 squared. So 2 squared would be 440 minus 4 plus 30 over 4 minus 3 would be 1 squared is still 1. So 70 minus 4 and 66 is the derivative evaluated at 2. Okay, so another quotient rule. In this case, f is going to be x to the 3/4. And then f prime is going to be 3/4 times the 1, x, and then 3/4 minus 1 would be minus 1/4, right? And then that's going to be the same thing as, so this is a negative exponent. And because I know where I'm going to go on this problem, I'm going to rewrite this that way, because that will help me in a second. And then let's see, so g is this little bundle of joy down here, x to the 1/4 plus 5. And so now my g prime is going to be 1/4 x. 1/4 minus 1 would put me 3/4 in the hole, right? So minus 3/4. So again, that one I could rewrite as 1/4 x to the 3/4. Okay, so now I got to set all that up as a product rule. So that is going to go f prime times g. So this right here times that. No, go. There's my g prime. So this times this. And then this times that. Okay, so the next is a bunch of canceling is going to happen. I'm going to rewrite this with these things distributed out, and then come back and then try to show you kind of where everything disappears to. So I will be right back. Okay, so here we go. So here's that last line I had. And then what I did was I just showed this distributed across, that's right here, and I showed this times that 1, and that's right there. So you can see that denominator at both these spots. So now let me show the canceling, and this is the part that's hard. So right here we have 1 x to the 1/4, x to the 1/4. So those are going to drop out. That part's cool. And then here, x to the 3/4, x to the 3/4. Those are going to drop out. So that part is cool. So now let me rewrite that. Okay, and that gets us to there. So I just have my 3/4, nothing happened there. Everything canceled, so you can think of that as like a 1 times. And then 3/4 minus 1/4 would leave me 2/4. So let me sneak down here. Okay, so 3/4 minus 1/4 left me 2/4. And then I have fractions in my fractions. And at this point, I really could plug in that 1 and do the problem out. I'm going to, if it's a problem, like remember what we were doing way back here was we're finding the derivative evaluated at 1. Once I got the derivative, I could have plugged the 1 in there. I don't have to do the simplify. But just to be complete, let me show you the simplify. In an exam situation, if I just say evaluate it at 1, once you have the derivative, you can plug it in and skip the simplify steps. But here it is, because if you're asked to actually find the derivative, then you need this step. So the trick here is to clear the denominator of fractions. So I'm going to use the LCD. And I would not ask you to do the simplify on a test, but here it is. So right here, the 4 over 4 would cancel, leaving a 2, oops, let me get rid of that parenthesis, 2x to the 1/4. Right here, it all cancels, so I just get plus 15. And then this just stays as it is. So if all I was trying to do was get the derivative, I would have it. That would be it. But now we are still trying to find this evaluated at 1. So and again, I did some kind of fancy algebra here. Way back here, if I plug 1 into this and manage to get through all those little calculations that are going to be a little messy, it's not that messy with a 1, I would get the exact same answer as I will here in the simplified form. So if all you need to do is find the value, you can do that back there. I'm showing you all this because if you needed to find the actual derivative, that was it right there. Okay, so then we're going to plug a 1 in here, and we'll get 2 times 1 to the 1/4 plus 15. 4 times 1 to the 1/4, 1 to the 1/4 plus 5, and quantity squared. Oops, I just realized I cut this out of the frame when I was recording. So 2 times, this is just be a 1 because the 4th root of 1 is 1. So that's just 2 and 15 for 17. 4 times 1 for 4. 1 and 5 would be 6 squared for 36. And then 17 over 144 would be the answer. Okay, so for this one, you have a couple of choices. You could do product rule, right? Which would be fine. I would probably do, I would probably just FOIL it, honestly. I think I'm just gonna do that. So I'm gonna go root t times root t, and those square roots would just clean each other up because I get root t squared, which just makes t. And this is still g of t. I haven't found a derivative yet. On the outside, I get plus 3 root t's. On the inside, I get minus 4 root t's. And out there, I get minus 12. Collecting these, I have g of t equals t. 3 minus 4 leave me minus 1. And we wouldn't really write the 1 there. It's like the 1x. Oh, let's say I said x, so I wrote x. That's looking terrible. Sorry. T minus root t, and then minus 12. And then the only other thing I would do to that is this root isn't super helpful because we're about to try to take the derivative. So let's rewrite that as t and then minus t to the 1/2 minus 12. And now we'll find our g of t, or g prime of t. So that's a 1. So 1 times 1 would be 1, and then take away 1 off the exponent, and you get t to the 0. So this is just a 1, which makes sense, because what's the slope of that line? 1. It would just be the invisible 1 in front. Here we'll go minus 1/2, and then t, and 1/2 minus 1 would make negative 1/2. Or if I wanted to clean that up a little tiny bit, I could say this is 1 minus 1 over 2 root t. And this, if I was trying to find g of t, I should write that with a single denominator, but I'm not. I'm just going to find g prime of 1. So g prime, tossed in right there. That's as good a spot as any. It would be 1 minus 2, and then root 1, which is just 1 minus a half. Or we should end up at 1/2 there. Okay, so this last one we got, given this function, find all real numbers, so we're not worried about imaginary solutions in this course. So find all real numbers x for which f of x equals 0, so that's the original function set to 0. And the second part is find all real numbers for which the derivative equals 0. Okay, so let's do a first because that looks not too bad. So if I set the function to 0, I would have x squared plus 16 minus 16 equals 0. So there's 0 equals f of x. This is not going to have real solutions because when I set that to 0 and bring that over to solve, and I root both sides, you see I'm getting this root of a negative, so that would be plus or minus 4i. So this does not have real solutions. This side, however, I could solve the same way. I'd get x squared equals 16, and then when you root both sides, careful, do plus or minus 4, or you can think of this as a factor, x plus 4, x minus 4 equals 0, so there's the negative 4 and the positive 4. But just be careful if you do it the root way, which is to say x squared minus 16 equals 0, x squared equals 16. When you root both sides, you need that plus minus, otherwise you end up losing one of those solutions, which is pretty common. So the next thing we gotta do is find the derivative so we can set that to 0 and then find where the derivative is 0. So to do that, I could do product rule, or I could just, again, I could just FOIL in this section because there's not, the FOIL's pretty easy. When we get a couple more sections in, we won't get to be able to dodge the product rule as much as I'm dodging it in this section. So if I go x squared times x squared, that will be, so this is part B, x to the 4th. And then on the outside I get minus 16x squared, inside plus 16x squared, they cancel. And then 16 times 16 is going to be negative 256. So that's still f of x, right? I haven't, all I did was FOIL. So now I'll do f prime of x. So it will be 4x to the 3rd, and then that drops off because it's constant. So then the question was, where does f prime equal 0? So f prime is this equal to 0 at 0, right? Because if I divide the 4, I have x cubed equals 0, cube root both sides, x is still 0.